is a more than a Galaxy project is now more than a decade old. In fact, the first Galaxy developer meeting, I think, was 2009 or 2010, but the project started a few years before then. And it's a web-based bioinformatics environment, okay, where there are a number of public servers. We are going to be using one called usegalaxy.eu that is run by the European Galaxy community, that is supported by Elixir, their bioinformatics network. And but anybody can actually run their own Galaxy server. So we run one at Sanby. We are actually discussing setting up a larger Galaxy server for others in the initially the South African bioinformatics community. But if you don't want to, or if you're not in a position to run your own server, then usegalaxy.eu has access to quite a lot of high performance computing environments behind the scenes. You don't need to worry about that, but it does mean that you've got a freely accessible place to do your Galaxy analysis, and they give you by default 250 gigs of data, okay? But besides the software, it's very, very importantly, a community of users, trainers, and contributors. So the project is open source, as I mentioned, and then you've heard about open source, I'm sure, a lot this week. But what's also open source is the training material. It's produced by a community called the Galaxy Training Network. And the tools that, so it's a web-based environment for accessing bioinformatics, but of course, you know, there are so many bioinformatics tools. So connecting the web interface to the tools, that's also done by contributors. So there's a lot of places where you can get involved. And the main principles of the project are that we aim to make bioinformatics accessible, both in the sense of making it accessible to those who don't have familiarity with command line interface, and also making it accessible by making public resources available. We want to make analyses reusable. So, you know, we often read the methods section of a paper, and then it's like, well, how exactly did they do this? I mean, the worst, of course, is when they say analysis was done with a custom script, which is only available if you email the authors, maybe, and then it's really difficult to actually do that same analysis that they did. And then, as I said, it's open source, and also the training materials in particular try and follow the FAIR principles, that the training is findable, that we can find it easily, that it's accessible, it's interoperable between the different Galaxy servers, and it's reusable. So that means that we try and not have the situation where you know, a workshop happens somewhere and then training happens, and then when you want to do your own workshop at your own institution, then you have to start developing the training from scratch. So reusability of training materials is a big thing with the Galaxy community. Okay, so how can you get started? So you can, I've mentioned two of the big public servers, usegalaxy.eu, that's running in Europe, led by a team at the University of Freiburg in Germany, and usegalaxy.org, which is running in the USA. They have largely got the same kind of the same tools available on them. The galaxyproject.org main website advertises events, and sometimes there are free training workshops that now in our days of Zoom you can join online. So you can get help either on the Bioinformatics Hub of Kenya Slack. You know, during this workshop, there will be, I will keep an eye on that to answer any questions, at least for this afternoon in between my various meetings. And then there are forums, so help.galaxyproject.org, where you can ask problems if you get stuck. And then there's a Gitter chat channel. So Gitter is just a form of chat, like WhatsApp or any of the other things, but you can run it in a browser. And there's a chat channel for the Galaxy Training Network, which is both where trainers have discussions, and also where if people get stuck with some of the training materials, you can ask questions, okay? And then we have regular community calls. So the Galaxy Training Network has, I think, quarterly calls. Every month there's something called the paper cuts day. And so that is an opportunity to choose little like projects, like fix up some typos in some training material, or fix a bug in a particular tool or something like that. So the paper cuts events allow people who are relatively new to contributing to become familiar with contributing towards an open source project, and particularly the different parts of the Galaxy project. So if you're feeling more confident, then please look at those opportunities to contribute. Okay, so for those who've not seen Galaxy before, the web interface has these three parts. Here, in the middle, we just get status of or the outputs of running tools. On the left, we get the list of all the tools which are available. And on the right, we have what's called the history. So the history is basically data sets. So we see here 2 data sets and the status of whether the analysis is completed. So green means the analysis is done and everything worked out. And the effectively one analysis is one history. You can think of this as a folder, okay? When I talk about tools here, so we see, that these are different tool sections, but so for instance, there's FastQ quality control. You might be familiar with a tool like FastQC, you'll find that here. So to get a tool into Galaxy, firstly, the tool needs to be installable. So that typically means that there should be a bioconda recipe. So the bioconda project makes little packages for bioinformatics tools. And so if there's a bioconda recipe describing how to install the tool, that's the starting point, okay? And then secondly, so then you can install the tool with bioconda, and then, many or most bioinformatics tools are command line oriented. So then there's a tool wrapper that gets written that connects the user interface of Galaxy to the command line of the tool. So in other words, what does the form look like for filling in parameters, and how does that translate into how to actually run the tool? So there's a community of people creating these wrappers. And then finally, the administrator of the Galaxy server needs to add the tool to the Galaxy server. So this is a picture of usegalaxy.org, usegalaxy.eu. Actually, there's just a file on GitHub where you can request via a pull request to have your tool added to the usegalaxy.eu server. So recently, for instance, I was working with some people who were working with Sanger data, and there's quite a nice little tool called Tracy for working with this. So I wrote some wrappers for the Tracy command line tool. And then I contributed the wrappers again, like you've just heard about pull requests and things. So I made some pull requests to the tools IUC GitHub repository that basically got reviewed by the people from the IUC group that checked that my tools were good quality. And then those eventually got added to the collection of tools you can install. And then I went to the usegalaxy.eu admin people, and again via pull request I said, okay, we've got these new tools for Galaxy, let's add them to the server, and now they're in Galaxy for working with Sanger data. So that's the basic process of how tools get there. And then how do you get data into this thing? So it's sitting on the web somewhere. So there's a web interface, so you can upload the data if you have it on your local computer. You can just upload via the web browser. That is perfectly fine for most data. But the second option is that the Galaxy servers can have an associated FTP server. So if you have big data that you're worried that you're not going to be able to keep the browser open like the whole time, or maybe you want to upload from another server that you don't have a graphical interface on, then you can upload via FTP client, and then Galaxy will pick it up from there, okay, to the FTP, from the FTP server. And there's a new interface called remote files. I've linked to a talk on how this works. If I have some time, I will show a demo. of this, and that's basically looking into how to link Galaxy to remote resources. There's some experimental work on linking Galaxy to Dropbox, but also, you know, that you can browse, for instance, the NCBI website, or sorry, FTP sites, and collect data from there. But this remote files it's in development. The latest release of Galaxy, that's the 21.09 release, was just released a few days ago. And this is getting much more attention in the current development efforts of Galaxy, to basically make this work better. Okay, so then once you've got the data in there, how do you organize the data? Well, sorry, as I said, one history should be for one analysis. So don't try and not mix your different analyses in one history. It gets confusing. So histories you can think of as one folder, okay? And then when you're analyzing multiple samples, then they should be organized into collections. So if we, for instance, have FASTQ data, then, or let's start with FASTA data. So FASTA data, we want to work on multiple FASTA samples. We can then organize them into a collection, a so-called list collection. And then when you want to analyze the data, you can just use the whole collection as input. Sorry, I think just pressed the wrong button. Sorry, get my screen back. What's this? Sorry, Zoom is just messing with me. I just need to make that menu go away. Okay, can you see my slides again?
Yes.
Okay, so you can have all of the samples together, so you can analyze them all as a group. And there's a thing called the rule builder, and I've linked to a tutorial on using the rule builder, but the rule builder is something that you really are going to want to learn about if you want to use Galaxy for data analysis, because it allows you to choose data sets from your history or from your upload folders and organize them into a collection. For instance, a list of paired and FASTQs and so on. It's a very useful tool, okay? Because, I mean, raising these things because you have to think about kind of data hygiene at the start of how you're organizing your analysis. So keeping your data cleanly organized. And then how are you going to learn how to work with Galaxy? So there's the Galaxy training network resources. In fact, I should have added a link here. I'll add this in a little bit, training.galaxyproject.org. That is the Galaxy training network resources. So there's tutorials on using Galaxy and on doing various analyses such as RNA-seq or assembly of samples or whatever various topics in Galaxy. As I said, it's community contributed resource, so it does keep growing. There's extensive tutorials now on doing your SARS-CoV-2 analysis in Galaxy if you're working on that pathogen. Individual tools can be combined into workflows. Okay, so there's a workflow editor within Galaxy. It's a graphical workflow editor. And then instead of running one analysis and another analysis, you can then run the entire workflow. And this is really great in terms of basically reproducible research, because now when you're going back to analyzing things, you can say, okay, I did all of this with this workflow. So therefore, if I want to do it again, I just run the same workflow. It's not a manual process. And then, of course, as I said at the start, you can contribute tools and training materials. So if you, for instance, are working on a new bioinformatics tool and you want more people to use it, you want to provide a graphical user interface to it, then add it to Galaxy. It's an easy way to get a bigger audience for your tool. And then if you want to grow a community of people working on your topic of interest, so for instance, you want to grow more people working on Plasmodium falciparum bioinformatics, then contribute training materials so that it's easier for people to learn how to work with the topic in question. Okay, so for several years, we've been talking about Galaxy Africa, which is the African community of Galaxy users. And I must admit to not having as much time as I would like to building communities, but what I see as the way forward for building Galaxy Africa. So we have to be identifying gaps. So which tools are people wanting to use? Are they packaged in Bioconda? Are they available via Galaxy? Which reference data sets are we using? So the so the pathogens that, or the organisms that we're looking at on the African continent are not necessarily priority organisms for other people. So do we have reference genomes for the particular species of mosquitoes we care about? Are they available in Galaxy? Do we have reference genomes for Leishmania and all of these things? And do people know where to find the reference data? Okay, and this is linked to training materials that basically we need to be growing the training materials collection, and then along with that, obviously doing train the trainer activities to grow the trainer community. And then we have a chat channel. It's really underutilized, but I put the link in here. If I do monitor this channel, but so we can have conversations in this channel about growing the Galaxy Africa community. Okay, so I'm going to switch soon to doing some practical demonstrations. First step, register on usegalaxy.eu. So that's anybody, it's free to register, but just go there and register on that website. Then once you've registered, click this link, okay? So I've put the link to the slides in the Slack, but I will put them into the chat as well. Let me just find where I put the chat. Sorry, 1 second. I have too many windows open as usual. Could somebody who's got access to the Slack, please just put the link in the chat as well. And then you'll find this link, and you can get to join the Training Infrastructure as a Service group. So what is TIAAS? What it means is that anybody who clicks this link will be registered as part of the training that we are doing. And you will get priority access. Your jobs will run faster than if you don't click this link. Also, for those of us who are the trainers, we'll be able to monitor your progress. We'll be able to see which tools have been run, okay? And then questions about the training, I've linked here again, the Galaxy Training Network lobby, but as I mentioned previously, we've also got the Slack where you can ask questions. So you can ask questions on the Slack, but after we are finished with this set of workshops, then this is the Galaxy Training Network link. Okay, so I'm going to switch gears now from these slides to doing some Galaxy tutorials. Okay, so I've linked them in the slides, and just going to skip past a little bit because I might run out of time to talk further about the slides. Once you're done, I've got a form. It would be great if you can fill in the survey about yourselves, and then yeah, keep the chat going on the Gitter and the Twitter, and let me switch off the slide presentation, and actually I'm going to jump into the practical training. But before I do that, I would like to just open the floor very briefly for 5 minutes perhaps of questions. But I'm going to switch off presenter mode here. Stop share. We'll go back to sharing in just a second. So are there any immediate questions? I don't see any hands raised. So either that was clear or I just talked so fast that nobody knows what I'm going on about. Okay. I just want to show you what you will see if you come to the Galaxy Europe as a unregistered person. So if you come to Galaxy Europe, it already says you got a history and you can run things. But look here, look at this button in the top corner. Okay, here it says login or register. Okay. Now, the other Galaxy link, which other Galaxy link? .org. Sorry, so you register here. Okay, use galaxy.eu. Okay, this is the website that I'm looking at. Okay. So just moving things around my screen. Okay, so this is usegalaxy.eu, interactive one. I don't understand your question, Mishak.
Sorry, can I just? You did give two links. One for registering and the other one for asking like questions where you said.
Oh, okay.
Yes.
So yeah, let me just give you the Gitter link for that. Gitter, yeah, this one. But we can also ask questions on the Slack, huh? So that's the Gitter. Yeah, I think that's all the links that were on that slide. Okay. So I'm just so anyway, talking about this page. If you haven't registered, then you will not be able to register for the training infrastructure as a service, and you will not be able to. There's a whole lot of things you can't do. You can't keep track of your history, and so on and so forth. So your starting point must be to go log in or register. And then when you get here, then you can either log in or you can click register here and then create an account, fill in all of these things. It will send an email to you asking you to confirm your registration. Okay. So make sure that you are registered and logged in and that you're not seeing this login or register button. I'm just going to close this window and switch to my logged in window. Share screen, share. Okay. Here back to sharing the screen. Okay. So when we are here, you can see I have quite some stuff already in my history. This is me, who's been doing things on usegalaxy.eu for quite some time, but I don't see the login or register button over here. It just says user, which is my user menu, and I see a little hat. Okay, so I provided the links in the slides to the different training materials, but this feature means that we can actually get to the training directly from within the Galaxy website. Okay, so I click that hat and a little pop-up shows here. It's showing the previous training that I was looking at. So I'm just going to go, hat, click this button. And when we see this, we should see a page that looks like this. Welcome to Galaxy Training. And there's various topics. Okay. I'm going to, by the way, is my screen big enough for people to read what's going on, or must I zoom in a bit?
Maybe zoom in a bit.
Okay, just zooming in. Is that a little bit better?
Yeah.
Okay. So having clicked the little scholar hat, we see this page. If you ever want to get back to the index of this materials, you just click in the top where it says Galaxy Training. And I'm going to go to the Introduction to Galaxy Analyses. Okay, that introduction section. And here we have various different icons. Okay, so what we have here, if we see a picture like this one, it's slides, just a slide presentation. The ones that I'm looking for are the ones that look like a little laptop. So I'm going to start with a short introduction to Galaxy. Okay. By the way, you see this little note here, Espanol. This is the first tutorial which has been translated from English into another language, and there is now a push to translate more materials from the training network into other languages. Okay, so I'm hoping that in future we have en français, and I don't know which other languages we can translate these materials into to make them more accessible. But anyway, when we click hands-on, Then we get taken into the tutorial itself, a short introduction to Galaxy and some description at the top of what is involved in the tutorial and what we will learn, okay? And then links to supporting materials like the slides and the data sets and the workflows. We will get them to these just now. So the tutorial talks about a few things that I've already spoken about, but so let's go through it. What does it look like, okay? So here's the Galaxy interface. We've already talked about register or login. I've mentioned the Galaxy servers at usegalaxy.eu and the usegalaxy.org in America. There's another one at usegalaxy.org.au. These three, the .eu, .org, and .org.au, are the three big ones that form the so-called usegalaxy.star servers, and they try and have the same tools available on all of those servers, okay? And as I said, there's the tool panel, the main page, and your histories. So starting point for anything you're doing is you start in a new history, okay? So when you start, I'm just going to click off the tutorial, get back to the main page. I'm going to click the plus button to create a new history, and you should see a page that looks like this when you log in. So you start off with a blank history and it has no name. So we want to give it a name, and I'm going to follow the tutorial exactly, and I'm going to click the name and I'm going to say my analysis. And now at least the history has got a name, okay? We're going to get to uploading a file in a second, but I just want to show, do you see here next to the plus button, there is a thing with two rectangles. If you click that, then that takes you to the multi-history view, okay? So I have so many histories, but you should just see on the left-hand side, my analysis, okay? When you're done looking at, this is how you can navigate between multiple histories. In other words, they're like multiple folders, but when you're done with that, then click the home to get back to your analysis view, okay? So let's get some data into this server, okay? So we can load data from our local computer, but you can also upload from other services. So I'm going to use the upload form, but I'm just going to go down here and copy this URL. So you see this URL refers to a dataset at zenodo.org, okay? So if I want to get data in, here's upload data. And here are the different options. I can choose a local file from my computer. Here's the remote files that I mentioned earlier, but I'm going to use the option called paste fetch data, okay? So when I click this, I could just, if I've got some small data, I could type something in here directly as a file, but I can also type in a link. So there's a link to a file that I want to download. And then which name should it have? Well, it's just one thing that I'm going to download. So I'm going to choose this file name, mutant_r1.fastq. I'm going to put it in the new file name box. And what type is it? Okay, so I'm just going to leave it as auto detect for now. It can figure out that this is a FASTQ file. Which genome is it from? I don't actually know, so I'm going to leave this blank. Okay, so once that's done, I click start. A little progress bar moves across, and then something happens in my history view. It's gray, and there's a little time icon. So what this means is that I've given Galaxy a job to do, but the job did not start running yet. Okay, now it's yellow, and there's a little moving circle thing, and that means that it's busy running. So behind the scenes, Galaxy is taking that link that I gave it, and it's going to fetch the link from the internet and upload it into my history. Okay, it's also, once it's got the data, it's going to run some basic statistics on the data. It's going to try and figure out what type of data am I looking at here. Okay, So if it's green, it means that the upload completed successfully. So what are we going to do with it next? One of the buttons we have, one of the ones here is the view button. So if the moment I click the view button, it takes over this middle part of my screen. So click the eye, and we can see here, this is familiar preview of FASTQ format reads. So here's some reads and their quality and so on and so forth. It says that this is a large data set and it's only showing the first megabyte. Okay. So I can then choose to download it if I want, but that's fine. It looks, this data looks fine. Then I'm going to just see what type of data is it. So I'm going to click on the title, and it says format FASTQ Sanger database is ? Okay, so this is, it's auto detection. It's detected that this is FASTQ data, and it has said that this is FASTQ data in the Sanger encoding. Okay, Sanger, there's different ways of encoding quality, but the most common one, almost all data we find these days is in this encoding. So it's picked up that the standard type of FASTQ data. Database is ? Means that it doesn't know which genome this came from, but that's fine. That's not important for the current analysis. So let's run a tool on it. When we're using the little hat icon tutorials, we can find the tools directly by these links, but I'm actually going to search for the tool. So I'm going to type here, search for tools, FastQC. And there's various things that match FastQC, and here's FastQC read quality report. So when I click on the tool, it puts the tool form in my middle view here, and it automatically chooses a data set that matches the input type that this tool expects, which is FastQ, and it says it can analyze that, and there's various other options for FastQC, but I don't need them because they're like advanced options. And once I'm done, I can go through the form and decide what I want to do with things. There's a bit of help here at the bottom of how to use the tool, and then I can click execute. And we see here that again, 2 new data sets gets added to my history. And again, they're gray because they're waiting to run. So one of the things with usegalaxy.eu is that behind the scenes, it's connected to many different kind of computing resources. And so it's busy trying to figure out which resource has time to run my job. And there it's busy running. And we see that there's going to be 2 outputs. The raw output from FastQC, which is more appropriate for a computer to read, and then the web page output from FastQC. Okay, so this is going to take a few seconds to run before we can view the results. Okay, so there it's finished. And look, if we look at the raw data there, it's raw data on the quality of our sequences. But let's look at with the eye icon here. This is a web page embedded within the Galaxy server. Okay, so it's kind of big. Notice here on the bottom, there are these little arrows. So I can click this arrow to make the left-hand tool panel go away. And we can see the analysis results. So what have we got here? This is 150 base pair reads. The quality is honestly looking excellent. A little bit weird at start, but it's you know, all above, pretty much all above quality 30. We can look at the distribution of sequence quality. Over here at the top, it tells us how many sequences. Well, 12,480 reads. It really isn't that many. And we can see that across the positions, there's the sequence content is just split between A's and C's and T's and G's like this, which gives us some idea that this is a highly AT rich set of data. We're not seeing ends anywhere. The sequences are all 150 base pairs long. And we're seeing a very low level of duplication. Okay, so just scrolling down, it's all saying this is all good news. This data set looks really good. Okay. And okay, let's run another tool. So when we are filtering short read data, we typically use quality trimming tools like FastP or Trimmomatic, but this is a very simplistic tool. And here, instead of searching for the tool by its name, I'm going to use this button to just find the tool for me. Sorry, I want to bring my tools bar back, so I'll click this arrow to bring it back. And this is the fast filter by quality tool. And what I want to filter this, and I want to put the quality cutoff value as 35. Okay. Just going to see if there's any other tips in the tutorial. And that 80% of the bases must at least have a quality value of 35. And the tutorial says I can just execute. Okay. Again, I'm waiting a few seconds, but so this is a like step-by-step analysis I'm showing at the moment, just running one tool after another, and the history is growing from the older data at the bottom to the newer data at the top. While that thing's running, I'm not really using this raw data file over here, okay? So I can choose to click this little checkbox thing, and then I can choose this file that I'm not working on, and using this menu, I can say hide data sets. You see now it says one hidden, click that off again, and now I'm only looking at the things that I really care about, which is the raw data, the web page, and the filter data by quality outputs, okay? So this says on data one, this ran on data one, and this is just FastQ data. That doesn't really show me much. So I'm sure the next thing that we can do is, sorry, they want us to look at what's the outputs here. And so we can see some of the metadata. Okay, so this is the parameters that we ran, 35 minimum quality, and the output is now 10,694 reads. Okay, so in other words, 14% of the reads were discarded. But now if I want to try a different set of parameters for the same tool, I don't need to go find the tool on the menu here again. I can just click. So sorry, just to illustrate again, I got to this by clicking on the title. I can just click the little recycle symbol over here, and that means run the tool again. Okay, so let's run it again. Let's just tweak this one parameter to 36 instead of 35. Keep that as 80. And we wait. Okay. So this is how it's easy to experiment with what the impact of different settings for a tool are when we are maybe new to a tool and its use. By the way, one of the effects of having signed up for the training infrastructure as a service is that my runs go from gray to yellow faster because I've got like a higher priority. So therefore, if I do this, wow, when I set the cutoff as 36, then I've discarded almost all of the data, 92% of the data. That seems that 36 is a bit too much to ask for this data set. Okay, so now I've been doing these things step by step, but I said earlier that if we want to do things reproducibly, we should make a workflow from the tools. So what I'm going to do here is I'm going to choose the history options, and I'm going to choose the selection called extract workflow. So it sees here, okay, which steps do I want in the workflow? I don't want to run both of these, but so let's say I just want to run FastQC and then filter by quality, okay? And then I'm going to say my first analysis workflow, and I'm going to say create workflow. Now it takes me into the workflow editor. No, it says that it has created the workflow. I can either run it again, but I want to edit it. So I'm going to choose this edit button. And here is my workflow. Okay, so I'm going to go here to the little options menu for the workflow editor, and I'm going to say auto layout and just spread things out a little bit. So here's an input data set. I can give it a label like input reads. And then this goes into FastQC. And then we have filter by quality, and we run it, and we see that the parameters that we chose during running the workflow, they're now chosen as the default parameters. But let's just add another step to the workflow to see what they want us to do with the workflow. But oopsie. Okay. So let's just say we want to do this, and then maybe we want to run FastQC again. So I can just click on the tool, and I can click this button, duplicate the tool. And now I can take the output from filter by quality, and I can run FastQC again. Okay. So now this will run these steps and without me having to manually do all of them. So now I'm going to save the workflow. And let me go back to my home page to look at my history. So let's make a new workflow. A new history. Okay, so here's a new blank history. And remember, I showed this multi-history view. And now I'm going to move this data set into this analysis. Okay, and I'm going to call this one my second analysis. I'm going to go back to the home page. Yeah, and then as I thought, so let's go to, now we want to run the workflow we just created. So to do that, I can either go down here to the bottom, I can look for all workflows in the workflows menu, or I can go to the workflow menu here at the top. And I have many workflows, but you have only one if you're following the tutorial. So then my analysis workflow, I can choose run it. Okay, so when I click run workflow, then it says, okay, here is what is the input? Do I want to send the results to a new history? No, I'm going to keep them in this history. What is the input? And then it shows me the parameters for the different tools. So I can go into filter by quality. I can click on it. I can change the value if I want, but I'm not going to. And I can check that everything is correct. And then I can click run workflow. Now we see what is called a workflow invocation. So it's basically loading the steps, trying to compute which steps are involved in running this workflow. And it says how many jobs are complete. Okay. So nothing is started running yet. So it's still computing the workflow. So just can see in the steps, FastQC, and it's still busy. Doesn't normally take this long to run a small workflow. There you go. Now it starts going. The steps start being scheduled. And we see here that it says that all the steps are scheduled. So it knows what work we need to do. And now it says how many jobs are complete. Okay. So there we can see them busy running. And notice that the FastQC is running at the same time as the filter by quality, because remember, both of those steps were only dependent on our input data. So it can run them in parallel, but the second FastQC didn't start running because that's dependent on the output from this step, this filter by quality. So now the second FastQC is running. Both of them, the running first FastQC is finished. And there you go, everything is done. And our workflow invocation is complete, okay? Workflows, I haven't shown it yet, but workflows can actually also have an invocation report. You can customize a report on how that ran. But let me just show you on the user menu, I can look at workflow invocations. And remember here, it shows this was my workflow invocation, and this is what happened. And then, as I said, there's this report. The report is not going to be terribly interesting because I haven't made a custom report, but you can view or download a PDF format workflow report, okay? So let's see what the results looked like. But now I want to compare, where's my data gone? Filter by quality. It is hidden in one of my workflows. Sorry, unhide. Okay, I'll explain why I did that just now. So I've got the two FastQCs. So the first FastQC before filtering, and then the FastQC after filtering. So I can look at them. Here's FastQC before filtering, and there's FastQC after filtering, but I would like to compare them side by side. So I click the Scratchbook button, and then I click the first data set I want to look at. Go back to the history and click the second data set. I can move them around or leave them like that. So I can see here what's going on. The first FastQ, so my second analysis, FastQC on data 1, that was the first one that I ran. FastQC on data 4, that was the second one that I ran. And I can see things change, like the number of total sequences. As we know, the filtering reduced some sequences. Scrolling down, I don't see a huge change, just a little bit of change in the per base sequence quality. It's just pushed it up a little bit, but this was pretty good quality sequence to begin with. Remember that we said that we're only filtering out sequences where 80% were at we're filtering out sequences that were not 80% were at quality 35 or above. So it doesn't change the start of the reads because it accepts that some reads can be a little bit below quality 35. Okay. Now that I'm finished with the scrapbook, I can click this, and now it will no longer add what I'm looking at to the scrapbook. Okay. Why did my data set show up as hidden? I think I know why. If I go back into my workflow and I edit it, then you see these ticks here, which items are shown as part of the history output. For some reason, I didn't have these selected. So that's why it created the data, but it was hidden when it was first created. So I've updated that, and I can save workflow. Okay, so I'm pretty much out of time for, I think, the first hour that was allocated to me. But in the slides, I've mentioned some of the other tutorials that are very interesting to look at as a beginner. Going back to the training materials, the next one that I recommend that you do is the Galaxy 101 tutorial. That is a more biologically interesting tutorial in terms of using the Galaxy interface. So you can find it here in the Introduction to Galaxy Analysis sections, and you can click on this button to follow the tutorial. But I think you have some time this afternoon for that. So I'm going to pause at this point and open the floor for questions.
Can I ask just a question, please?
Go ahead.
Okay, I'm just trying to trace back a path. Like what you've just shown was under tutorial.
Yeah, let me show you here. Go to the little Scholar Hub Galaxy Training, Introduction to Galaxy Analyses. And what I just showed you was in the tutorial, the hands-on tutorial for a short introduction to Galaxy. Okay, so I'm going to, let me just first chat. Basically, my little, let me just paste the survey link is here. And then let me go into this short introduction to Galaxy. And I'm going to paste the short introduction to Galaxy tutorial. And that's there. So if you want to just see this outside of the Galaxy server, that's the link you would follow.
Okay, thank you.
Just to illustrate that workflows can get a lot more complex than what I was showing. So this is one of the workflows that is used for SARS-CoV-2 analysis, created by my colleague Wolfgang Meyer. And you can see how many steps are involved in this analysis, okay? Wait, is this Wolfgang's one or is this my one? Let me see, this is Wolfgang's one. Okay, so you can see it has so many steps, okay? So there's a lot of things going on here, but from the user perspective, it's all one thing, okay? So in fact, this workflow is used by our National Institute for Communicable Diseases in South Africa to analyze SARS-CoV-2 sequences collected in the country. You know, it's used on wastewater analysis and various other things. So you really can get quite advanced in terms of Galaxy workflows. The one that I was illustrating was obviously just an introductory, quite basic one. Any further questions?
Peter, are you talking? You've been muted.
Man, sorry, I forgot that I was muted. So there are some auto-generated videos that have a robot voice, like this one is an auto-generated video. and it sounds a bit weird. But I will also share this link. Let me just find the Galaxy Training Network YouTube. Quite a few of these videos are available on YouTube. Okay, so I will try and find a better collection of links. But anyway, so this is the YouTube for Galaxy Training Network. Okay, in terms of sharing things on the Galaxy server, if we go here, share data, then we find we can share workflows with each other. So we can choose to do that. If I go to my own workflows, like this baby workflow that I created, then, so that's, sorry, just showing this shared data that's on the Galaxy server, other workflows. So you see, I see Wolfgang's made one for form of cancer analysis, single cell analysis by Nicolas Aranzo, and so on and so forth, okay? But also on the workflows menu, if I want to share with others, I can go to this button called share, and then I can make the workflow accessible via a link. So here is the link, and I'm just going to copy this link. Now, if you follow that link, you can share, you can get a copy of the workflow that I've just created. You can publish the workflow to the published workflow section. So yeah, there's many options there, but the user has to share the workflow explicitly. And what is starting to become a thing, it's not yet fully, I consider it fully like there, is the sharing between Galaxy servers. Okay, there's a thing called Workflowhub.eu. So if you publish a workflow, let's see, can I find my workflows on here? That's me. And there's let me just go back. Workflows. So here's the SANBI analysis, it's the SANBI workflow for COVID-19 or SARS-CoV-2 sequence analysis. And if I click on this thing, then from workflowhub.eu, then I can choose to run it on usegalaxy.eu. So Workflowhub is a emerging project for publishing workflows and sharing them between people. And I think it's going to be great, you know, that we can, you know, maybe even get citations for these things in the future, and make workflow authoring one of our main jobs. Okay, yeah, I think that I might be out of time. I'm not sure what the schedule is. I don't have it in front of me.
Your session is supposed to end at around 12:15, so you have around 1 more hour to go.
Sorry, I thought that I was only allocated 1 hour. I saw it incorrectly on my side. Great, great. Let's do another tutorial on Galaxy. Okay. So yeah, so I wanted to get into the next tutorial, but just allow me to just get myself a drink quickly. But I'm going to now do the Galaxy 101 tutorial. Okay. But obviously, what do I do before I start anything? I make a new history. So I'm going to call this one new history Galaxy 101, and I'll be back as soon as I've got something to drink.
You can take a 10-minute break.
10-minute break. Yeah. I think so. And in the break, please try and register and try and at least be ready to follow some of the steps yourselves. I know I'm going a little bit fast, but please don't only just look. Get ready to actually do some analysis.
So the links are in the chat. If you have any trouble setting up or creating an account, just put them in the chat and then we'll assist. Okay, you can see Peter is back. If anyone else is back, I've seen Audrey has managed to register for an account. Has anyone else managed to do that? Maybe just a thumbs up so that we know we are together and that also everyone is back.
I see we have 2 people registered, that is myself and one other person for the training infrastructure as a server. So obviously not a lot of people are following directly, but we've got time this afternoon to register and follow the tutorials. So okay. I noticed quite a few of you are familiar with the Linux command line. That's great. I would like to point out that it is possible to work between the Linux command line and Galaxy. In other words, do some analysis on the command line and interact with the Galaxy server. There are training materials on that. There is an API in Python, and there are some command line tools, but perhaps that is a topic for an advanced session. Okay, so I'm back here to my Galaxy 101 history. I'm in the analysis view here with the home analysis view. Let's bounce into the tutorial. So there's some overlap between this and the previous tutorial, but I will be going into more depth, okay? So what this tutorial is setting us up is in human chromosome 22, from the data that we've got available, which exon has the highest number of single nucleotide polymorphisms, okay? Now, this is going to be an interesting thing to look at because perhaps we might find some exons which are under some positive selection, you know, in the genome. Obviously, the limitation of the data is always going to be what is, you know, what is the data source? As we know, there's, you know, insufficient genome sequencing from African data sets. So that is a limitation in the public data, okay? The link with a FastQ file, sorry, from this morning's analysis, or from the earlier analysis, yes, that I will just hop back to the analysis to share the link. It is here at the top, Introduction to Galaxy Analyses, and it says a short introduction to Galaxy, hands-on. Actually, I want to show something else, just Galaxy Analyses. I just want to see if I can use this other link to get to it. You see here, it says short introduction, and there's a little paste icon. So if I click on that, it'll copy the data set into my, nah, it didn't copy anything. Sorry. Going to see if I can reset back. Didn't copy, so it's just a link here. So the link to the input data sets, and I can say copy link, and that is the link to the input, to where we find the input data. Okay, if we click on that, then we can find, I'm going to get another error now, I'm sure. This is the collection of input data, okay? So I used mutant R1 over here, okay? So this is the input data collection, or going back into the tutorial itself. Then I can scroll down and find here the direct link to the FastQ file that we were using. It's over here. There's the FastQ file, okay? So that's the FastQ file that was using for the first tutorial. But let's go back to the 101. Galaxy 101, okay. So in this tutorial, we are not going to be loading the genomic data directly into Galaxy. We're going to be querying from the UCSC genome repository, okay? So we've created an account, we've created a new history. We know approximately what the user interface looks like. And we're going to copy this data. Actually, we're not going to use UCSC directly, but we're going to copy this data. So I'm starting similar to how I started before, but now I'm copying these two links and I'm going into my upload data view, okay? And I'm going to paste fetch data, okay? But now slightly different to before, I can't give it a file name here because we're not saying one new file. Hang on 1 second. I just want to go lock up the front of my house quickly. Sorry, just keeping my dog out of the front yard. Okay, so as before, I'm pasting these links and I'm clicking start. But it has chosen the names from the link. So we see here the end of the link is this UCSC HG38 chromosome 22, etc. In older versions of Galaxy, okay, they are running the latest version of Galaxy on usegalaxy.eu. I'm not sure if they are doing the same. I'm just going to test something on usegalaxy.org. Usegalaxy.org. They might not have updated yet. Let me just check. /API/version. Let's see which version they're running today. Okay, they've also updated. Let me just see. I'm just going to try and find an older Galaxy server. And AU. Aha. So org AU, that's the Australian one, is running an older version of Galaxy, and I hope that I can illustrate the problem that I was talking about. The bed file, it's in the tutorial, okay? So if you follow the tutorial, you're going to get the link to the bed file. Just waiting for the Australian Galaxy to load. Yeah, actually, let me get a direct link to the tutorial here. Sorry, this tutorial is this one. This tutorial has the links to the bed file, etc. Okay, so here I am on Galaxy Australia. Okay, so I'm going to do the same thing. I need to log into this thing first. Sorry, while I log into Galaxy Australia. I've got to log in already on the server from the past. Just bear with me. Their server is obviously running a little bit slow today. Although not as slow as when I was doing a workshop in Sudan. Wow, that had slow internet that time. But okay. And by the way, you know, the funding that started usegalaxy.org.au, the Australian Galaxy server, was quite modest. I think their staff is only about 3 people running this server. So if we can get this kind of funding, we can maybe develop more Galaxy resources in Africa. But okay, I want to use the tutorial, the 101, and I want to get those bed file links. So introduction to Galaxy analyses. This is running the 21.05 release of Galaxy. So from earlier this year, Galaxy has new releases about twice a year. So I'm going to scroll down in the tutorial and I'm going to find this gray block with these links. Copy this. And I'm going to go back to my upload data thing. Paste fetch data, click this, start. Oh, I didn't start on a new history. Sorry. Just do that again. Upload data, paste, fetch data, start. Okay, well, it was obviously the even older versions. Okay, I want to just illustrate something here. So even 2105, it just uses the name. Older versions would put the whole link in here, okay, which was kind of ugly when you were having a whole link in the history. But the current versions of Galaxy just put the name in. So I just want to illustrate. So one of the things that you'd want to do if you don't like the name they've given you, so just to illustrate what it used to look like. And so let's imagine that you got a history which has a long name here. So if you want to change the name of a data set, you click the pencil icon on the data set. And now we can edit this to be whatever we want it to be, okay? So sample one. I think somebody forgot to mute. Okay? But anyway, let me carry on with the tutorial here. So I've switched to the usegalaxy.org.au server, but I can carry on working on this one because it's the same for doing the tutorial, okay? And these data sets was downloaded from UCSC, and if you want to expand this box here, it tells you that you can actually go use the UCSC table browser to get it directly, but we're making our lives easier by getting the bed files directly in from the Zenodo collection, okay? So, okay, so now we've got some data. Let's just have a look at it again. We've got two bed files. The one is, let me just verify what I've uploaded here. Oopsie, I messed up my history. I'm just going to start again, delete these files. Copy this, paste this again, upload data. So what I've got here is a bed file, which is just listing the positions of exons in chromosome 22. And then I've got a bed file, which is listing the SNP positions. I'm going to look at them quickly. So this is just the, just waiting for it to load. Here are the ensemble gene names of the different, the ensemble names of the different exons and their positions on chromosome 22, which strand they're on, and so on and so forth. And here we have the well-known names of SNPs and the positions that you find these SNPs in chromosome 22, okay? So that's what the data is that we're going to work with. Now I want to intersect these two things. So I'm going to use the bed tools intersect tool, and I want to intersect where the exons and the SNPs intersect, okay? And so A and B, and let's go back here. So I want the exons file and then the bed file. So that's going to be A and that's going to be B, okay? Then I want one output per file for input file B. So that's the default selection. And I'm interested in overlaps on either strand because the exon, I mean, the SNPs are just positions. They're not so much stranded. And then I want to write the original B for every overlap. Okay, so let's think about what we're doing here. B for every overlap. Just confirming the selection. Okay, so basically what effectively am I doing here? I'm taking the exon positions file and I'm finding only the the SNPs which are in these, which are within these exons. So obviously intergenic SNPs I'm not interested in at this point. And I will leave the other parameters as default and I will click execute. Okay, so I'm effectively filtering the exons file by filtering the SNPs file by the exon positions. And then when I do that, let's check that the data looks like what we've got. And we've got here, there is the chromosome, this is the exons, and then this is the SNP that is within that exon. Okay. Now, I want to go from just this list of SNPs and exons into a count of how many SNPs are in which exons. Okay. So I'm going to use the data mesh tool. And I'm going to use the intersection as the input. And I'm going to want to use the operations perform, which is to count the unique values. Okay. So where's my data mesh? Count on column 10. Let me just confirm that I'm doing the correct thing. And I'm going to group by fields. So I'm going to group column 4. So just to remember, column 4 is the name of the exon. And then I want to count, which is column 10, which is the unique names of the SNPs. And I'm going to give this operations on each group. Sorry, group by fields on count unique values. Should be fine. Count unique values. Yeah, so it's just not just count, but count unique values. And this is column 10. And I think that's all that I need. And then I can run this tool. Yeah. So I'm grouping my data on column 4, and I'm counting the unique values in each group of column 4. Okay. So let's see what the results look like. 4,242 lines. And let's see what's so what does this 4,242 lines mean? So remember, what were we grouping on? Going back to this intersection, what is column 4? 1, 2, 3, 4. Column 4 is the exon name. So what do we think this 4,242 lines represents when we get this in our output? So at the start, we had here the betools intersect. We had 6,719 regions, okay? And then if we group by the column 4, and we're now getting 4,242 lines, what do you think these 4,242 lines represent? Do you think that these 4,242 lines represent SNPs or exons or something else? Can somebody give me some input? Or have I lost you entirely? let me go through this thinking a bit slower, okay? So the bed tools intersect is an intersection of exon and SNP, and then exon and SNP, okay? So look at these first two lines here, right? So here's an exon ID and another exon ID. I'm going to just zoom my window a little bit so that it's easier to read. Look, these exon IDs, they are the same, okay? But of course we have, so what this means is that in this file, this is one exon that has two SNPs happening within that same exon, okay? So once you use data mash, this would be reduced to a single entry. So let's look at the data mash output. We recognize here that there's the exon name and the count is 2. So 2 exons within the SNP. So here, instead of having 2 entries for one exon, then there's only 1 entry for each exon. So that means that there's 4,242 lines from the data mash output. It is a count of how many exons there are that have SNPs in them on chromosome 22 human, okay? So there's 4,242 exons. And then we can see here different counts of SNPs. But which one has the most SNPs? Okay, we're going to use the sort tool. And we're going to sort which was the column that had the number of SNPs in. It's going to be column 2. And it's a numerical sort, and we want descending order. So biggest numbers at the top. Execute. Should only take a few seconds. As I said, I'm working on the Australian server. The same analysis can be done on the European or the American server. It's going to be the same. And in fact, I could probably do the same analysis on the Sanbi server. So after that sorting, we see that this exon over here is the one that has 27 SNPs in, okay? That is the exon with the most SNPs. Maybe we want to look at the only a few of the exons. So we're going to use a tool to just, let's choose the first 5, the top 5 candidates with SNPs. So I'm going to say select first tool. If I'm saying the top 5 from this file, what would this tool be called if it was running on the Linux command line? Can anybody think what tool I'm basically running here? First lines from a data set. This is basically head, right? So if I'm doing this thing, so the bed tools intersect, obviously there's a bed command line tool called bed tools, and then I'm running the bed tools intersect, and then data mash. I don't actually know what the command line tool is for this, but perhaps this would be an awk script. And then sort, we've got a command line tool called sort, and the top lines, that's head. So effectively I've run here bed tools followed by maybe an awk script, a sort command, and then head, okay? Just to see what is actually happening on the command line, I'm going to click on this guy, and I'm going to click on the title, and then I'm going to click the info button. I want to know more about what's going on. And look here, it shows me that I'm running a command called data mash. I didn't actually know this tool existed. Sorry. Where's that gone? You can see here, I got here by clicking the I button. So in other words, click the title, click the I button, more information about what's going on here. And then it shows me my command line. There was nothing in the standard output or the standard input. So we can just see over here what the command was. So if we want to move between Galaxy and the command line, we can also use Galaxy to learn more about what the command line tools do. Okay, so again, going back to my bed tools. I click I. And I can see this was the bed tools command that I ran to get these results. Okay, so the Galaxy web interface, it's always an interface around command line tools. Well, almost always. Okay, so now we've now determined which are the top 5 exons that have the most SNPs on chromosome 22. Okay, but in the process, look what our output looks like. We've just got exon names. Where is this exon on the chromosome? Okay, it makes so now we might want to bring this data back about locations. And so what I can do is I can use the compare datasets tool to select this output. Let me just actually I'm going to choose the exons file, and I want to use the column 1 here from the exons file. And then I want to take the output of select first, and I want to compare, sorry, of course, column 4 of the exons file was the name of the exon, and column 1 of the select first is the name of the exon, okay? And I want to find matching rows of first data set. Click that. Effectively, I'm going to now pull the full data out of the exons data set, but only for where it's matching the select first, okay? So these, remember, select first here is data 7. I'm just going to edit the name here, and I'm going to call this one exons with highest numbers of SNPs, just to make it easier to understand what my data, what my entry is about. But the output from compared data sets, it's now the bed file, which gives me the position of the exon, and these are the exons in question. Now I want to go back to displaying this data in the UCSC genome browser, but to do that, I need to be sure that this thing knows that this is HG38 human data. So I'm clicking the title. Database is question mark. Okay, so I must tell it, interpret this data in terms of the HG38 database. Okay, so I'm going to go here with a pencil icon, and I'm going to say, which database is it? And I'm going to type HG38, which is the latest version of HG38, the patch 11 version. I'm going to click save. And now I should be able to click on the visualize, click down here, and you can see display at at UCSC. Okay, so let me just check that this is okay. So it's got the test release of UCSC. Let's just check that this works. The reason that it didn't know that this was UCSC, I mean that this was human data, is when I imported the bed files at the start, I didn't associate them with the database. You see, it says here question mark. So it didn't know that this was human data. Okay. Now there's a problem with my data because of the chromosome names. This is a common problem, chromosome 22. And it says here that there's an error. correct is chromosome 1, incorrect is chromosome 1, incorrect is 1. But this is saying chromosome 22. Chromosome names are case sensitive. So this could not locate chromosome 22 and this position in GRCA. That's odd because I gave it the correct chromosome name. Let me see if I can just fix this. UCSC genome browser. Should work. Maybe it's because of using the test. Not sure why it's only letting me display UCSC test. Okay, let me just check if it's a problem which database that I've got associated with the data set here. So they say that I should use just HG38, the human from, not the latest one, just the one from 2013. And save that, changing to HG38. Okay, so when I do that, then I get the option to view at the main UCSC, not just the test UCSC. And I want to see if that allows me to visualize my bed on the human chromosome correctly. Ah, there you go. So that means that I've got a user track, and here are the look at this user track, and you see here are the positions on chromosome 22 of the exons that I was talking about. So I'm going to zoom in a bit here. User supplied track. So now I just need to put a chromosome range of interest here. So I'm going to take this one, this position. So I'm going to say this to chromosome 22. Let me just hope that I get the format correct. Let's zoom in on one of these exons. And we see, I'm just going to zoom out a little bit, zoom out 3 times. This is the exon that I identified as having many SNPs in. We can find out more about it. Click, so you see, sorry, that click, that this is overlapping this exon, and clicking on it, we find out more about human gene ZBED4. So this is how we can move from Galaxy to the UCSC genome browser, which is its whole own tutorial actually. And yeah. And then we talked about multi-history view earlier. And then again, we can turn this analysis into a workflow. Let me just illustrate. This is a more interesting workflow than the one that we had before. So I'm going to go to my history options, and I'm going to go extract workflow. And then which are the things I want to bed tools, intersect, data match, sort, select first, compare to data sets. I want all of these, and I'm going to need 2 inputs, and I'm going to say from bed to counts, okay? And exons. Create workflow. And then I can edit the workflow. So here it's going to take 2 inputs, and I'm going to call the one input exons. I'm going to put the other exon, other one, I'm going to call it SNPs. And then bed tools intersect. I'm going to use this option to just auto layout. It's a totally linear workflow from one input to the next. So I'm just going to move things around a little bit so it's easier to see how the data flows. So this is intersect the exons, then use data mesh to identify which ones I care about. Sorry, to identify the counts. Then I'm going to sort, select the first, and then compare the 2 data sets to extract the exons specifically. Okay. Now, looking at all these checkboxes, I can see that like all of these outputs are selected, but do I really care about the outputs? No. If I want to just know about which are the exons with the top number of SNPs, then then maybe I only care about the select first list and the output of the top exon. So I'm going to unselect all the others. Okay. So having done that, I save my workflow. And now from my workflow editor, I can in fact run the workflow. Just waiting for the Galaxy server to load. And my inputs, I'm going to choose the SNPs and the exons. And I want, let's see the whole form. And I want to make a new history, okay? So I'm going to call this beds from count top exons with SNPs. I'm going to call this history. And then I'm going to click, sorry, inputs are SNPs and exons, run workflow. So we're back to the workflow invocation screen, and it's scheduled all the different steps. And now I don't see what's happening because it's in the other history. We can just see these are the inputs, these are the steps. So I'm going to just switch over to the other history where you see it's busy creating this history from this workflow. So I'm just going to switch to that as my primary history. Go back to the main analysis view. And it in fact finished running already. And you see that it used the input dates from the other history, and we can just see the output results are here. This is the final bed for the exons, and this is the select where we can see the count of the number of SNPs. Okay, so let's see what else can we discuss in the Galaxy 101. I mean, I've again moved through it rather fast, extracting the workflow, convert your analysis into workflow editor, and run the workflow on some different data. I didn't go into that. And then you can share your work. I mentioned earlier, making the history accessible, making a workflow accessible, but you can actually share your workflow via a link as well. Okay. So yeah, so please take the time to go through that Galaxy 101 tutorial yourself. And the other tutorials that I wanted to talk about, let me just double check my slides. Yeah, I'm not going to have time to really work through this in detail, but one of the tutorials that I find really useful is the tutorial on the rule-based uploader. Okay. Okay, so I'm just going to pause there just for a few seconds. Are there any questions specifically on the Galaxy 101 that I just finished running through? I think you might have more questions once you've done it yourselves. Just want to see in my status view. Then, yeah, a few of you have registered now for the training infrastructure as a service, but yeah. I've got a few minutes left, so I would like to just go through this, just show you the tutorial on the rule-based uploader. That's in this section, no longer in the introduction section. That is in this section on using Galaxy and managing your data. And you see here, it's got two little scholar hats suggesting that this is an intermediate level tutorial, okay? And this tutorial is about, like, if you say have a whole collection of data from the European Nucleotide Archive and you want to download it and organize it. So let's take this. This is a collection of data. And then if we had all of this data, if we just loaded it individually, it would be quite tedious in our history. Sorry, I'm going to just start with a new history again. So you can follow the tutorial, but from the, I want to make some collections. Haven't really illustrated collections yet, but the rule-based uploader gives you like a way to build formulas for organizing your data. So we've got here, this is some data in typical ENA format. Here's some files. This is where the data is located. And now we want to make some rules, okay? This one is not as easy to use with a little tool, with a little hat icon. But I just want to illustrate a few things about it. Back to my uploader. So here we could say that, for instance, tell it that column D is the URL where we want to fetch the data. Column C is the list identifier, that this is, we can see here that this is a sample name, and I'm just going to apply those for now. But if I scroll around, we see that this is paired end. No, this is not paired end data. Let me just check. Yeah, so this is single end FASTQ data, and then we can say that this is, for argument's sake, well, this is FASTQ Sanger .gzipped data. Let's just have a look here. Yep, gzipped FASTQ data, and then let me just imagine that this is Drosophila. I don't know if it really is, or DM software melanogaster. Let's take, just for argument's sake, say it's that, okay? And then we can choose a name tag for the name, and I can say that this is just a collection called samples. Oops, but that was not good. Okay. I can go back to the rule builder. What's gone wrong? List identifier. Oh, it said column A. I made a mistake here. Going back, this is column D, should be the URL. Apply that. So that's the URL, that's the list identifier. And upload. It still has an error, and I don't know what the error is. AD is the URL. Oh, goodness, of course. Look at this. It's got a header line. So let me filter here, and I want to not have this first line because it's a header line. Oops, not like that. I want the filter the other way around. I want to not have the first row. No. Okay, I want to remove, filter out the first row, and then use this as a URL that is a list identifier. Let's see if this works now. Yeah. So the point with the rule-based uploader or the rule-based collection builder tool is that you can organize your data, you can manipulate it. I haven't shown in full detail what you can do with it, but you can basically go from unstructured data to structured data within Galaxy. It then goes and behind the scenes, it's going and downloading all of those files from Zenodo and organizing them into a list of samples. And then because it's a collection, I would be able to run a tool on the collection. So for instance, FastQC, and then it would run the tool once for each member of that collection. I will illustrate that as soon as those samples have uploaded, which will take a few minutes. But just going to close this. The list is going to be empty until it's finished downloading those data sets from zenodo.org, which will take a few minutes. And because it's an empty list, I don't think I can run FastQC on it yet. Let me just check. Yeah, no, because it does not recognize that this is FastQ data yet until it's finished processing it. Just going to go back into the tutorial and just have a look at something here on Zenodo. Just going to copy this link, Zenodo, and that link over there. So these data sets that I've selected, I'm just going to see, I don't know how big they actually are because they might take a little while to download. And my network is also playing up a little bit here. Ah, okay, so it's finished loading them. There are the 6 items. I can see there's FastQ data. I don't know why my network is playing up like this. Okay, so this is, there's your FastQ data. So if I run FastQC on these, it says there's no FastQ data. Ah, it's correct. There is no FastQ data. There's a collection of FastQ data. So I choose this data set collection thing. I run on all of the collection, execute. And now you see this progress bar that I've got over here. What's it doing? It's going to start 6 jobs, and it's going to run those 6 jobs in parallel. This is usegalaxy.org.au. Behind the scenes, it has its own high performance computing cluster, a bit like the usegalaxy.org.eu. So the usegalaxy.eu, the .org.au also has access to a number of different computing facilities. And now it's run analysis on all 6 of those items. So I can see the web pages for each. Just gonna have a quick look. Wait for it to load. See, here's the web page on each one. And in fact, I can use the multi-QC tool. I think I can use the multi-QC tool to combine all of these outputs. Just check. And multi-QC, I'm going to say, yep, all of that data, combine it into a single report. Multi-QC is an amazing tool that can, oh, up. Did I even tell it that that was data from, yeah, I've made a mistake. I've made a mistake because I didn't tell it that that was data from FastQC. So let's run that again, multi-QC. And this, you see, I must first select that this is FastQC output. And I must say, I want the raw data from FastQC and execute. This should work this time. You see here, there's the individual samples, percentage of duplicates, GC content, and then down here we have the quality histograms for the individual samples. They all look basically the same, except, wow, this is not nice data. This is dropping down to low quality. It's long reads, but look how the quality just drops as we go across the sample. I'm not sure which technology this is, and then we'd have to do some quality trimming. We would not be able to use this data as it is. But again, when we did quality trimming, we could treat the whole collection as one thing using a tool like Trimmomatic. We could trim it all together, or FastP, whatever it is, trim the quality and then use it for our later analyses. But yeah, so this is you know, you can manually organize things into collections with Galaxy by using this little menu over here. But this is an illustration of how you can use the rule-based tools, or the rule builder, or what it gets called, different things in different places, to organize all your data into one thing and then analyze it all in once. Okay. But I've spoken a lot, and I think there's a lot of homework to do in a way. And I look forward to see how you engage with Galaxy. And as I said, there are further steps in terms of building the Galaxy community, both in terms of running more training and also in terms of building the capacity of Galaxy with reference data sets and tools appropriate for your different analyses.
Awesome. Thank you so much, Peter. Are there any questions? Would anyone like to ask Peter any questions?